everybody. Welcome to my talk on ChanSIP and ChanPJSIP, a talk that I've brought up in various forms before, but with the potential impending doom of ChanSIP, it's always good to go over stuff again. However, before we start, hi, my name is Joshua Colp. You can also call me Josh. You may also know me as File or jcolp across various other places, such as the forums and also the issue tracker. And then on Twitter, you can find me at JoshNet. Feel free to actually follow me, reach out, talk. Do note, however, if you follow me, you'll be seeing stuff about voice over IP, Asterisk, communications, the industry, alongside cycling, financial stuff, and then occasionally dog pictures. So if the only reason you'll follow me is dog pictures, I'm totally okay with that. So from an Asterisk perspective, I've actually been part of the project for over 17 years now. I've seen Asterisk grow from the days of when it was in CVS to bringing it over to Subversion, finally to Git, and the evolution of many of our processes and projects, so such as adding testing and the benefits of that as well. And in particular for PJSIP, I'm actually one of the co-developers of the original PJSIP support. So myself and an individual named Mark Michelson, who is a former Digium employee, were actually the main people behind creating the PJSIP support in Asterisk. So I know a lot of things about PJSIP. That being said, I've also created many other things in Asterisk. I was the original creator of the bridging support, which Richard Mudgett took over and improved quite a lot. But there's also other aspects of it, such as our improved DNS support, which I will touch on in a little bit. However, don't panic, but ChanSIP will be disabled by default as of Asterisk 19. So that means if you install Asterisk 19 or 20, ChanSIP will not be built by default. You'll need to use the menu select utility to go in and explicitly enable it. So the code is still there, you'll just need to turn it on yourself. However, this only buys you a little bit of time because ChanSIP will actually be removed as of Asterisk 21. So at that point, all of the code will be gone and you will not be able to go into menu select and enable it. So if you haven't started looking at moving to PJSIP, now is the time. So let's talk about that a bit. First, we're going to take a look at ChanSIP woes. So I've approached this broken up a bit into a developer and user perspective. There is some overlap in ways since the developer aspect influences the user part, but I felt it was important to touch on each individually. So ChanSIP in Asterisk is from a time when Asterisk really, development was from the perspective of what do we need right now to make this work. And so ChanSIP fell into that category. We needed a module to support SIP to talk to phones and providers. And so one was quickly put together. The result of this is that it really hasn't had a design philosophy or a defined way that things should be written. So really the evolution of it has been from an organic growth. As people have needed things, you've basically had to figure out the best way to put it in with little guidance generally. Unfortunately, the result of this is that the code is not really organized very well and it's not documented very well. So it's really been a pain to maintain, unfortunately, from a developer perspective. And also no one truly understands it all. And even those who may understand parts of it, things have changed such that what they think they know may not be true anymore. Another thing that this has caused is that changes generally lead to regressions. In the past few years, any changes to ChanSIP have come from the community. And while they have gone through code review only serves for a specific part. Unless you have a true vision of how everything fits together, you can't really code review things to the best that's possible, essentially. So I went back in the past and looked at the percentage of changes that led to regressions, And unfortunately, that was about 75%. So 3/4 of the time, any change that went in actually caused a regression that had to be resolved. So it's just really hard to make changes and not break things. As well, without any defined way to do things, it's been really hard to extend or add things to ChanSIP. Essentially, you have to, on your own, figure out the best place to put things, and it may or may not be correct, and it could cause regressions. And finally, it doesn't exactly implement SIP how you're supposed to. ChanSIP takes a very simplistic view of SIP in ways, and so it doesn't implement some of the things you're supposed to, such as transactions. A transaction is where you send a request and then you receive one or more responses. That transaction is supposed to get retransmitted and supposed to stick around to a certain point so that retransmissions properly work. ChanSIP doesn't have a concept of transactions, and in the past, a lot of time actually went into adding protection to off-nominal cases which were actually observed in the real world to handle the lack of transactions as best as possible without them. So from a user perspective, one of the nice things that ChanSIP has for it is that there are well-known limitations and vast documentation. Unfortunately for the documentation, because ChanSIP has grown organically, so has the documentation in a way. Documentation can be of vastly varying quality. Some documentation can use options that are no longer applicable or have been changed around. Some may just use options that the person who wrote the documentation didn't really understand and can actually cause harm. So while the documentation is a good thing, it's also a bad thing. One of the things that has in recent times been problematic for users is that ChanSIP doesn't meet the needs of modern providers. Modern providers can end up having traffic sent from multiple different IP addresses to your machine. And in ChanSIP, you would have to configure each individual IP address as its own peer, which can be problematic. It also has hard to understand unique concepts. So peers, users, friends, while these may seem approachable to some, they can also be confusing because they're really concepts within ChanSIP, and the behavior of them has actually changed over time to cause further confusion. So what's a peer, what's a user, and what's a friend? I think some people can try to define those, but if you look at the code, the definition may be completely different. So PJSIP was a fresh start. We didn't carry any baggage over from ChanSIP, but we did learn things from ChanSIP and applied them to PJSIP. So we gained a solid foundation there, and we built on it. So let's talk about PJSIP. PJSIP is not a project from Asterisk. It is its own open source project. It's available at pjsip.org, so you can yourself download it and use it in your own products and projects if you want. It is open source. It does have a company backing it called Telu. It was first released in February of 2005, so it's been around quite a long time. It's seen a lot of different other SIP implementations as it's talked to them. It also has wide platform availability, so you can use it on Linux, Windows, iOS, Android embedded. And while I haven't put it on here, you can of course use it on macOS as well. And it's also widely used. Chances are you've used it without realizing it. So it's popular with Android soft phones. It's also been used on iPhones as well. And it's also been used in physical hard phones. We use PJSIP a bit differently though. PJSIP actually provides a framework for phones to build phones, but Asterisk itself isn't a phone. It has different usage patterns. So we instead treat it more as a low-level SIP stack, so it can handle the low-level SIP aspects of things. That would be dialogues, transactions, creating SIP messages, parsing SIP messages, that kind of stuff. That being said, where PJSIP has higher level features that we can leverage and make the most sense, we certainly use those. So that would be pubsub and outbound registration. Pubsub being publish and subscribing, so seeing your blinky lights on your phone when someone is receiving a call. Those handle basically the higher level, keeping the state alive and doing the maintenance of the state. Instead, since the low-level SIP aspect of things is taken care of for us, we focus on building features on top of it. So that would be better outbound registration support, calling support, that kind of stuff. And we are also contributors to PJSIP itself. So through implementing any features, if we do need to make changes to PJSIP, then naturally we contribute those back to that open source project and make it available to other projects. And a fun fact, the first release including was the first release of Asterisk 12 in December of 2013. So that is almost 8 years ago at this point that PJSIP support has been in Asterisk. So it's been around a long time and certainly gotten more stable and more full of features. There have been some things we've contributed that I'd like to touch on. So pluggable DNS support. While PJSIP does have DNS support, it has its own DNS client, it has its own implementation of the SIP specification for handling that. We did want additional functionality that PJSIP at the time did not actually have. So we evaluated whether that was something we wanted to do directly in PJSIP or whether it was something we wanted to do in the core of Asterisk and then use in other places as well as SIP. Ultimately, we decided to do it within Asterisk, which has been a benefit. In fact, in the past few months, we've actually had a contribution that leverages that DNS support such that in the RTP configuration, if you specify a stun address, that DNS support is now leveraged to periodically update that address if it changes based on the DNS TTL. And that was made possible due to the DNS support we added to Asterisk. However, having DNS support in Asterisk is one thing. We needed to be able to plug that into PJSIP. So we added support for plugging in an alternate DNS implementation and contributed that back up to PJSIP. And that was accepted, and I believe actually other projects ended up using that functionality to make their own DNS support be used instead. While in the past, they actually had to maintain their own patch. So that was good. And then we've also contributed numerous crash fixes and transport-related fixes. Asterisk being a server has a different usage pattern and characteristics to that of a phone. On a phone, traditionally, you may have, upwards of maybe 6 or 8 phone calls going on at a time if you're doing a conference on the phone. And for transport, for TCP and TLS, you might have 1 or 2 connections going on. But for a server, you have considerably more. And that actually brought out issues within PJSIP that we then fixed and contributed back to them. Fundamentally, we don't want to be a fork of PJSIP. We just want to keep our usage of it as pure as possible. So we contribute everything upstream we can, and that's something we continue to do so to this day. That being said, there are changes that we do maintain, and those are strictly build related. So it's to better build PJSIP when used with Asterisk. So from an approach perspective, when it comes to PJSIP and Asterisk, we want to be as modular as reasonable and possible. ChanSIP has a single module, chan_SIP. PJSIP has numerous modules with various bits of functionality, to the degree that if you're not doing an outbound registration, you don't need to build or load that functionality. We also want to be as pluggable as reasonable and possible. So this is to allow developers to extend functionality as any way that they basically wish. So we provide mechanisms that allow them to hook into various places. However, this is not something that's just used for external modules. It's also used internally for core modules for PJSIP. So going back to outbound registration, that module uses the same pluggable areas as another developer might. We also don't want to reinvent the wheel. So this is both from an implementation perspective and also terminology. For the implementation, if PJSIP has something and it does what we need, we will happily use it. For terminology, you're not going to find things like users, friends, and peers. We pull from terminology from the industry instead. So you might have endpoints, context, AORs, which have outside meaning outside of the Asterisk project. And then something else that was fundamental to the PJSIP approach was explicit configuration with sensible defaults. So an issue that some people run into with ChanSIP is that it's actually extremely forgiving in the configuration you give it, such that it may or may not output a warning or an error that the configuration you provided has something wrong with it. That being said, it will still continue to run. The result of which is that if you're not paying attention, it's not running with the configuration that you intended, and then the behavior may not match what you want. So that's a different approach in PJSIP, which I'll touch on here soon. So PJSIP installation, chances are that you've actually been building with PJSIP already. So as of Asterisk 16 and above, we've automatically enabled something we call bundled support. So bundled doesn't mean that we include a copy of PJSIP in Asterisk. Instead, what happens is that we download a copy of PJSIP that has been tested with the version of Asterisk in use. So that means we don't use the latest version of PJSIP. We use a tested version. And this is because we found that in some cases, PJSIP has made changes that we need to adjust Asterisk to better fit or to build with. And so if we use the absolute latest version, then you may encounter a case where Asterisk doesn't build, and that would not be good. Another thing of bundled is that we include any unreleased PJSIP fixes that have gone upstream, but we may also bring back fixes that are in PJSIP already, but are applicable to our version of PJSIP that's currently in use. So generally, those are crash fixes. As well, another thing is that we build PJSIP using a configuration which is best for Asterisk. I touched on this previously, but not all PJSIP builds are equal as it can be customized. So by default, PJSIP will be built with a configuration which is best for a phone, but Asterisk is not a phone. So we provide a custom configuration to better fit that. One of the things, and a good example, is the number of simultaneous TCP and TLS connections we can handle. By default, that's not many because a phone doesn't need many. But if you're a server serving tons of phones, chances are you're going to need more than the default. So we build with a configuration that includes. So ChanSIP configuration, while it does use some core configuration functionality, which essentially takes the text files that define your configuration and turns it into something which can be read and interpreted, all of the handling of that is actually defined within ChanSIP. As well, users, peers, and friends define the configuration for talking to things, and incoming calls get matched to them in an order. I've specified in an order because the order of that, some people may not realize this, has changed a few times over time. These days, I believe it's first user or friend followed by a peer, which can be problematic in some circumstances. So all configuration is in a single section for talking to something. However, outbound registration is configured in the general section. The general section can contain some configuration options which may or may not be inherited by the single sections. when a individual implements the option, they have to remember to do that inheritance, and sometimes that gets forgotten. Another thing is that naming of configuration options has also grown organically. Some options were misnamed in the past and have since been adjusted, but documentation is not always updated. A good example of this is can reinvite, which caused quite a bit of confusion in that the option makes it seem as though you're configuring whether Asterisk will do a reinvite or not, or allow a reinvite or not, when in practice, it was always and remains to configure whether Asterisk does direct media to directly send audio between two things. So that was changed over to the direct media option instead. And then real-time support and behavior is completely embedded and defined by ChanSIP. Something that catches people out is if they're using real-time and they inspect the configured peers, generally they don't see anything because that doesn't query real-time. It can be quite confusing for users. PJSIP, on the other hand, is using a newish API called sorcery. Generally, if you see anything which is named cleverly in some way, so sorcery being one of it, another one internally for doing retrieval of like files and stuff is called bucket. Generally, those come from me. I just like naming things interestingly. So sorcery is our modern API for doing configuration. It may not always be used by modules. It really depends on how they expect to be used, but it is seeing a lot of use these days. So the way sorcery works is that it takes information from a backend being referred to as a wizard in here, but backend might come from a database, it might come from a file. There's also wizards for the Asterisk database and also one for doing in-memory stuff. And so the wizards take that information and turn it into information that sorcery itself can then use. And then sorcery takes that information and turns it into an object that can be used by the actual user of sorcery. So in this case, that would be PJSIP. One of the nice things that sorcery does do, much to the annoyance at times of some developers, is it does enforce documentation. So if you add a new option, then sorcery will force you to document that option. The module won't even load in developer mode without that documentation being present. Another nice thing, in contrast to ChanSIP, is that it attempts to avoid ambiguous configuration using validation. A good example of this is an option that takes a yes or a no. If you put in potato, that's an invalid value, and the entire thing won't load. It'll output an error or a warning telling you that, but it won't actually load it, and it won't work. So if you configure an endpoint with that, chances are you're going to try to use that endpoint, but the endpoint's not going to work, which is then going to prompt you to check the logs and the configuration and hopefully see that you've made a mistake. And once you change that, then it'll load properly. The premise behind this being that it doesn't want to be in a state where you intended to configure it a certain way, and then it's not going to behave in that certain way. And another nice thing for developers is that created objects are immutable. They can't change through their lifetime. You don't need to worry about locking or things changing out from under you. You can just use the information as provided and not have to worry about that. Another nice thing of sorcery is that it has a highly flexible caching functionality. So the cache is kept in memory. It's great for use with real-time, and in fact, the Sangoma Switchbox product uses this. It is built on real-time, and it does use the caching. It's much more configurable than the ChanSIP caching functionality for real-time. So you can configure it per object type. So endpoints may have a different configuration than other types. Configuration can include how many you want to cache at one time, how long they can be cached, And another nice functionality is staleness. So this allows a stale object to be returned from the cache instantly, while in the background, it's actually asynchronously updating. And this ensures that anything which is querying the cache doesn't get blocked for a long period of time, where you may be consulting a database, for example. As well, there is control over this, so you can control it using AMI or the console. So you can say, expire a specific object. If you have a web GUI and someone makes a change to that specific object, then you can use these to explicitly expire that and then cause it to update. As well, you don't have to cache just individual things. You can cache the entire known world of an object, which is a good way of reducing the amount that your backend gets hit. So this is written to balance complexity and performance. So PJSIP configuration uses sorcery, just like I said. The types in it are industry or technology terms. An endpoint has a meaning in the industry. An AOR has a meaning within SIP. It means an address of record, which is a fancy way of saying take a named thing such as Josh and then map it to a list of ways to contact Josh. So the list of ways are called contacts, and then the contacts are SIP addresses. So it supports real-time and flat file configuration. By default, it does use flat file configuration just like ChanSIP. Thanks to sorcery, it won't allow invalid objects to be created as a result of bad configuration. And the CLI, and this is different to ChanSIP, reflects reality, rather, no matter the source. So that includes real-time and flat file configuration. If you do a PJSIP show endpoints and everything's in real time, it's still going to show all your endpoints. So there shouldn't be any confusion there. So some types, like I said, endpoints. This is a configuration we use when talking to another SIP device. An AOR, address of record, holds inbound registrations. So when your phone tells Asterisk how to talk to it, that's stored as part of an AOR. Identify, this is a type which identifies incoming traffic based on criteria. That could be an IP address and port, host name, a header, that kind of stuff. An auth section, as you might guess, is how you define inbound or outbound authentication credentials. And then we also have an explicit configuration type for outbound registrations, instead of using a single line in a general section like ChanSIP does. So here's a basic example SIP user without authentication. Type equals user, allow. If you've never seen the exclamation point, it basically means do the opposite. So this effectively becomes disallow equals all, allow uloss. It's a shortcut that some people use, some people don't. You can use it if you wish. And then a context of users. An endpoint is pretty much the same. It just says type equals endpoint. Here's an example SIP outbound registration for ChanSIP. This is under the general section, and all of the information about the outbound registration is on a single register line, which from a developer perspective is quite a headache because you have to interpret this string of information and figure out what each part means. So from a developer perspective, it's not particularly friendly. Unlike ChanSIP, PJSIP itself has a separate section where you explicitly define each configuration thing. So this is the equivalent. So we want to configure an outbound registration. Server URI is the address that is used to actually talk to the register server. Client URI is what we are registering to. So that would be the AOR we're registering to. And then contact user is the user we place in the contact we provide to the server. Some servers respect that, some don't. It depends. So here's an example SIP user with authentication. So I've just thrown in a secret equals super secret because that's a super secret password. And then for PJSIP, we actually have an explicit configuration section to do authentication. So we want to specify the authentication type, in this case, username and password. You can also do it as MD5, where you take care of part of the MD5 authentication. And we also specify a username and password. So this is something to point out between ChanSIP and PJSIP. In ChanSIP, it's referred to as a secret. In PJSIP, we call it a password instead. So here's an example SIP peer. This is for actually doing a call from Asterisk to another SIP entity. So the only difference really here is that we specify the host, which is a host name or an IP address that we actually want to contact them on. For PJSIP, the actual host is not part of the endpoint. We actually have another configuration section called an AOR, where we explicitly state the contact that is used to make contact with that remote SIP server. So a big difference in PJSIP, we have multiple configuration sections and options. We don't try to condense everything into a single option. We also don't try to condense everything into a single line, like in the case of outbound registration. We prefer having different sections and objects which reference others. So an endpoint referencing authentication, or an endpoint referencing an AOR. However, some people do prefer it simpler. So we have something called configuration wizards. And what these do behind the scenes is that they create all of these different objects for you based on a simplified configuration. And then using configuration templates, you can even reduce that more if you want. And this means you don't need to think about the individual sections of endpoints, authentication, AORs, etc. These are stored in a separate PJSIP_wizard.conf configuration file. So take a gander in there for some information, but here's some examples. So this is if you're configuring a phone. So it's typed as wizard. Accept registrations means we're accepting a registration attempt from the phone. Accept authentication means we want the phone to authenticate to us. And then inbound auth configures the username and password to use. And then we can also define the endpoint specific information like codecs to use, as well as the codec, or the context rather, that their incoming calls should be directed. An ITSP is slightly different. Instead, we want to send authentication to them. So if they challenge us for authentication, then we'll respond with it. We also want to send registration to them. So we want to send a register request and make sure that we're registered. And we also configure the host names that we use for talking to them. And then the rest is the outbound authentication to use and the context to use if they call us, as well as the AOR qualify frequency, which is basically how often we send them a SIP request to make sure that they're still functional in there. So some gotchas that I've actually had some individuals bring up on the forums, the IRC chats, and various other places. PJSIP uses RFC 4733 for out-of-band RTP DTMF, not RFC 2833. However, it is the same implementation. It's just different names in configuration. So in PJSIP, for the DTMF mode, you want to use RFC 4733 instead of RFC 2833 like ChanSIP. Another thing is that PJSIP uses SIP URIs instead of host names with ports, and these can carry transport type as well. So if you, for example, on an AOR, you specify a contact which just says 1.1.1.1, that's not going to work because it's not actually a URI. You would need to put SIP : in front of that to have it actually work. And PJSIP will notify you of this stuff. Documentation for PJSIP is on the wiki, so wiki.asterisk.org. It is updated nightly. There's a complete PJSIP configuration section, which has complete examples of different scenarios. So like if you're configuring an ITSP or a phone, I highly suggest looking at those. It also goes into showing you the relationships between the different configuration sections, so how authentication relates to endpoint and that kind of stuff. So it's a great resource. Please take advantage of it. So some other common configuration questions that I've seen. Why so many configuration objects? So we wanted to put down a foundation which was extremely flexible. So other things could then be built on top of it. For example, config wizards, which is considerably easier to do than the reverse, where you take a simplified look and try to make it as configurable as possible. That just tends to end to overloading things and a lot of confusion. So why no general section? It simplifies the implementation greatly, and there's actually ways to leverage existing functionality to get close to what the general section provided in ChanSIP. As well, why do the configuration parameter names have understorms? Understorms. Ooh, understorms. That would be interesting. Underscores. This actually allows automatic naming to occur for console and AMI commands. In the case of ChanSIP, when a developer added new functionality or a new option, they actually had to remember to go in and add displaying that to all the various places. Unfortunately, that was sometimes forgotten, and so things wouldn't be displayed. However, through using sorcery and some of the functionality it has, we were able to make this automatically happen for developers, which is a much better experience. So as soon as someone adds an option, we can automatically make it appear in the various places where it needs to be displayed without them having to do anything. So in regards to the general section, a feature that has grown in popularity lately, I would hope, because I've brought it up a lot, but who knows, is configuration templates. So this applies not just to PJSIP, but anywhere you can use a configuration file in Asterisk. You can define templates by adding the exclamation point at the end of a section, which gives you can put in there any settings and any values that you'd like to use as a template. And then when you define another object, you can then reference that template. And so object will automatically inherit all of the settings and values from the template and then apply its own. So in this case, object actually becomes setting equal value and setting to equals value. So you could, in the world of PJSIP, you could make a template which is your default phone template. And then in each phone, you'd only have to change a few things or add a few things. So it saves you from having the typing. And also, if you need to update everything, then you can just update the template if it's a global kind of thing. So dialing SIP devices. Dialing SIP devices, the way of dialing devices with ChanSIP has grown tremendously over time. I couldn't even, I think this list would actually encompass 2 slides if I based it on the documentation and the code, but there's a considerable number. And it's, from a developer perspective, that's incredibly hard to parse and understand. So you've got SIP/peer, SIP/peer/extension, SIP/extension at peer, SIP/host, SIP/username, password at host, and many more. In PJSIP, we currently only support technically 3. So PJSIP/endpoint, PJSIP/extension at endpoint, and that's one that catches up ChanSIP people who use PJSIP, or rather SIP/peer/extension. In that case, you need to change to using the PJSIP/extension at endpoint format. We also allow arbitrary dialing of SIP URI using PJSIP/endpoint/SIP URI. And you'll note here that an endpoint is always specified. So internally, there's always an endpoint associated with a session. And from a developer perspective, this greatly simplifies the code and provides some assurance to a degree. It makes it so developers don't have to write code that says, if there's an endpoint, do this, otherwise do that. So it's just better on developers overall and produces better code. So let's look a little bit at ChanSIP modules themselves. So res PJSIP, it really binds Asterisk to PJSIP and provides the low-level functionality, APIs, and helpers. An example helper being add a header to a SIP message of a given name and value. This is something we found came up a few times, so we added it as a helper function. It also handles all of the threading model for PJSIP, and it also provides an API that other modules can use to handle SIP requests. So let's talk about threading a bit. This might go over the head of some people, but I think it's important to talk about. So in ChanSIP, you have one thread for all of the UDP traffic and scheduled items. And while not on here, that thread is also what handles the reloading of your configuration. So if you make a configuration change, you're actually going to block your UDP traffic as well. There's also one thread for each TCP, TLS, and WebSocket connection. And we also have one thread for each channel generally. The consequence for the UDP and scheduled items part is that if something blocks, like that reload I was talking about, or a database access, DNS lookup, then your DNS requests are also going to be blocked, which can be problematic. PJSIP takes a different approach to threading. So there is still one thread for network traffic, so that's UDP, TCP, TLS, and timer. However, we use a dispatch module or a dispatch model where the actual requests are handed over to another thread. And that pool of threads is configurable. You can make it a fixed number. You can also have it grow and shrink based on the load on your system. We also have one thread for each WebSocket and WebSocket secure connection, one thread for each channel generally, and one thread for scheduled items. And as well, all PJSIP related interaction occurs within a specific pool of threads. Another thing on here that you may have noticed I didn't mention is configuration. This is not handled in any of these threads. It is handled in the thread that asks for the reload to occur, and it's done in such a fashion that it minimally interrupts any of these other threads. So the goal was to make it so we could handle more traffic and also ensure that configuration didn't interrupt things to the best of its ability. So the traffic distributor is something that hopefully most developers never have to think about. All network traffic is received in one thread, and then we distribute that out to worker threads for handling to that pool. A cool thing is distribution is done in a predictable fashion. So all the SIP traffic for a dialog goes to a specific queue, and that guarantees that those messages are handled in order. And it also makes it easier for developers because developers generally don't have to think about or worry about blocking when they're implementing PJSIP functionality. Another nice thing that developers generally don't have to think about is the distributor also takes care of interrupting who a SIP message is from and also authenticating them early on. So by the time you get your request, it's past all of this, you know who they are, they're authenticated, you're good to go. And any individual blocking of any of these threads does not impact other threads. So that's quite nice. So I've talked about endpoint identification a bit, but all traffic is associated with an endpoint for reasons I touched on previously. It just makes it a heck of a lot easier for developers. So this process is what is called endpoint identification. When we get a request, that's passed to a list of endpoint identifiers who examine the SIP request, and then according to their business logic, determine who that could be. In contrast to ChanSIP, this is not a fixed order and can be configured in the global section. So if you want to do IP-based matching before username-based matching, you can completely do that. And another nice thing is that this is completely pluggable and is actually leveraged in another place, which I'll catch on in a little bit. So ChanSIP, on the other hand, there's no configurability for this really, and it's not pluggable. So SIP services are the low-level mechanism for handling SIP requests. It's what things like incoming register, handle it, invite requests, they all use this to hook in and handle those. And then any unhandled SIP requests that don't have a hook get a 501 not implemented automatically. Res PJSIP session, that is what handles what most of us would call calls. So that's what handles the invite SIP requests, and it itself also provides an API for handling calls, and we call that API session supplements, and we call calls sessions. So it also handles SDP negotiation for your media. Something I'd like to touch on here is that we do not use the PJ media support in PJSIP except for SDP parsing and negotiation. So the media flow itself is the same as ChanSIP. So this module handles the life cycle of sessions and calls, and it also provides helpers for doing common things that developers would like to. A good example is sending a reinvite to renegotiate, which can happen if you're manipulating media or you're doing connected line updates. So session supplements, these are those higher level hooks for handling SIP messages within a session. Most session functionality is actually implemented using them, and there is a controllable order that allows them to be invoked in a certain order. A good example of this is actually caller ID support, which is itself its own module. So it uses this to hook in and receive and send caller ID information as configured. And ChanPJSIP, in comparison to ChanSIP, is actually a really small module. And it's the glue between the Asterisk core and the Res PJSIP session module. So it implements the API defined by Asterisk that all channels need to implement, and it effectively translates those requests into equivalent PJSIP ones. A good example is if PJSIP is told to send ringing to someone, then this module turns that into a 180 ringing SIP response and ensures that gets sent out to the session. So the Res PJSIP SDP RTP module is what handles the SDP part of RTP sessions, of RTP streams rather, and it is what actually acts as the glue between our common RTP API called RTP Engine and the PJSIP session. And it also takes care of handling the life cycle of those and handling the reading and the writing of that media. So the registrar, and registrar is yet another term within SIP itself, is what provides the functionality for handling inbound register requests. So this is when your phone talks to Asterisk and say, hey, here I am. If you need to contact me, here's how you can do it. And so that module handles that interaction. It manages the AORs, so address of records, like I talked about previously, and then the contacts on them. And it enforces any configuration you may have applied to AORs, such as how many there are, expiration times, that kind of stuff. And by default, this does also leverage sorcery. And by default, it stores the registers in the Asterisk database, much like ChanSIP does by default. So if you're using this and you want to see, you can just do a database show on the Asterisk console and you'll see them in there. Unlike ChanSIP, they are stored as JSON payloads instead, just because that's easier to parse and convert back and forth, and is also easier to extend if we want to persist more information. So pubsub handles ye olde flashy blinking lights on your phone. It provides the functionality for handling incoming subscribe requests. It does use the PJSIP pubsub API, However, it also does provide its own API that other modules can use to handle the various types of content that can be requested. So, for example, dialog info plus XML, PIDF plus XML, that kind of stuff. And it handles the life cycle of subscription. It provides the notification of things. So when we get a new subscription, when one expires. And a nice feature that PJSIP has, which ChanSIP doesn't have, is when Asterisk is restarted, it can actually recreate those subscriptions. So the phone is none the wiser that Asterisk has restarted, and it will continue to receive pubsub notify requests. So extension state is what handles subscriptions for extension state. Extension state is what we call it internally. It's kind of exposed in the dial plan as the extension state dial plan function, but most people commonly know it as hints. So you configure hints in the dial plan, and that turns into extension state internally. So this module acts as the glue between extension state and PJSIP, and it also allows the different event and body types to consume the information as they see fit. So if Asterisk tells something that's subscribed to dialog-info plus XML that it's ringing, then the module which is registered with this will receive that information and turn it into the appropriate notify request. So some nice things that PJSIP has that ChanSIP doesn't. Line support. Line support in outbound registrations. Traditionally in ChanSIP, when you send an outbound registration, you also have to configure it to all of the IP addresses that you may receive calls from. In PJSIP, for some providers, what you can do instead is enable line support. And this just adds a randomly generated string to your outbound registration, which the remote side is supposed to, but doesn't always, preserve when they send calls to you. So outbound registration registers its own endpoint identifier using the endpoint identifier API that examines incoming calls. And if it sees this randomly generated string, it knows that that call is related to your outbound registration, and then it can just match the configured endpoint. This saves you from having to configure an identify section with all of the possible IP addresses. So like I said, it's not supported by all SIP implementations, even though the standards say it should be. So this is something you really have to try and see if it works for you. I am aware it is working for some, and people are quite happy with it since they don't have to deal with configuring IP addresses and keeping them up to date. That's quite nice. If, however, line support doesn't work for you, or you don't do outbound registration, the identify section, which like I said, is for matching incoming traffic based on an address or a header. The identify section does allow you to specify multiple IP addresses. You can also specify ranges, and it does also accept a host name that it will then resolve for all of the A records, as well as quad A records and also SRV records. So that's cool. And then all this traffic is associated back to a single endpoint, so you don't need to configure multiple like you would in ChanSIP, where you have to configure multiple peers. So SRV, NAFTR, load balancing, and failover. So unlike ChanSIP, DNS resolution occurs when a SIP request is sent to a host name. The result is not stored in an external DNS cache, except in the case of, for example, if you have a DNS cache on your network, or maybe if you're using the Unbound support, it can also be configured to cache results. So DNS happens asynchronously, unlike ChanSIP. Load balancing will also occur based on the result of the DNS lookup automatically. And if a connection fails or certain response is received, then failover will occur to a new target. We also support A and Quad A records. There is a preference on Quad A records. And another thing to note about this is that it is intelligent in its resolution. So if you don't have any IPv6 configured, it's not going to look for those. If you don't have TCP and TLS configured, it's not going to look for those. It will only attempt resolution for things that it can actually use. Media stream support. So multiple streams can be negotiated in SDP for video. Streams can be added and removed as needed by Asterisk applications. And this is what is actually used for the WebRTC video conferencing support. So that support only works with PJSIP because of this. So another thing is multiple contacts on AOR. AORs, or address of records, like I said, can be configured to allow multiple contacts with policy. This allows multiple phones to register using the same endpoint, identification, authentication, and AOR. So you could have 2 desk phones on your desk register to the same thing, and it would work perfectly fine. They can all be called at once. So that's nice. In ChanSIP, this is not possible. If you register to the same SIP peer, then only one is registered at a time. The latest one will displace the previous one. And then another one is music on hold pass-through, which can cause confusion at times. So by default, when Asterisk receives a hold request from a phone, Asterisk is the source of the music on hold. In some cases, you may not want this to be the case. You may want to pass this information through to an upstream PBX or a provider. And so if you enable this option, then Asterisk will send a reinvite to that upstream PBX or provider, and it will then be their responsibility to provide hold music to whoever is on the other side. So this may be useful to some. Give it a try. So if you don't have a plan to move to PJSIP, now is the time to make one. You're on borrowed time. Like I said, ChanSIP is going to be in the tree, albeit you will have to enable it for another 2 years or so, after which point it is going to be removed. So I highly suggest, if you're not using PJSIP now, putting together a lab environment, trying it out, getting your feet wet, and then gradually moving your production environments over as you can. So thank you very much for hearing about ChanSIP and ChanPJSIP and some of the awesome reasons for switching to ChanPJSIP. If you have any questions after this, even after the Q&A, feel free to follow me on Twitter and reach out. My handle is JoshNet. I look forward to hearing from you. And now Q&A.